What is radius vector? Radius vector is a vector drawn from center of circle to the position of particle, indicating the position of particle with respect to center of circle. This radius vector is having the magnitude equal to radius of circle, that remain always constant. Means this radius vector remain always constant in magnitude but continuously changes in direction as it is away from center of circle towards the particle where the particle is being on the circumference of circle. The relation between the linear distance length or the length of arc and the angle covered. That relation between the length of arc and angle covered is like this. Length of arc is nothing but the radius into what? Angle subtended. So S is nothing but equal to r theta. In vector form it can be taken as delta S bar equal to delta theta bar cross r bar. First of all, about the angular velocity in details again. So what about the angular velocity is? Angular velocity is nothing but angular displacement per unit time, that is omega bar. Angular velocity is denoted by omega. Omega bar is the angular velocity, theta bar upon t, angular displacement upon time, radian per second is the unit. Relation between the linear and angular velocity. Very simple relation between the linear and angular velocity. By definition, linear velocity is linear displacement per unit time. Then delta S is the linear displacement, delta theta is the angular displacement. We know relation between the length of arc and the angle subtended. Length of arc delta S, angle subtended delta theta. Then V equal to what? R into delta theta upon delta t. We are just replace delta S by R into delta theta. Replace this one. So V equal to R into delta theta upon delta t. But this one is the angular velocity. But by definition delta theta by delta t is the angular velocity. So V equal to R omega. In vector form likhna hai to again with the help of directions. Again with the help of direction, linear velocity, angular velocity, apply the right hand thumb rule. Then what is angular acceleration? Again in details. Angular acceleration is the rate of change of angular velocity, that is denoted by alpha. Change in the angular velocity upon time, that is d omega upon dt. Alpha is vector quantity, direction given by right hand thumb rule. Then angular acceleration is related to the linear acceleration, like S related to theta, V related to omega. Similarly at, that is tangential acceleration, related to the angular acceleration alpha, again by means of this radius vector. Linear acceleration produced due to change in linear velocity, angular acceleration produced due to change in angular velocity. So now relation between A and alpha, at equal to r alpha, that can be expressed in vector form like this. All these linears and angulars, once we'll summarize all of them: displacement, velocity, acceleration. In magnitude, S equal to r theta, V equal to r omega, at equal to r alpha. Then in vector form, S bar equal to V bar equal to at bar equal to. During numericals you will require only magnitudes.